Okay, good evening, everybody. So, my name is Vinay Kumar. So, I'll be taking you through data visualization using Python, the webinar on data visualization using Python. So, I've been around 10 years in training, right? And before that, for around 20 years, I've been in the industry, working in various domains. So, for the last 10 years, I've been into data analysis using Python in various organizations from a training perspective. So, today, what we will do is we will take a look at four aspects. We'll look at the introduction to data science flow, the modules of Python that are available for data visualization, primarily Matplotlib and Seaborn. Matplotlib is our focus today. And what is the framework of the plots, right? There must be some architecture for the plots, right? And we will do a demo on the COVID-19 database and see some visualization, basic visualization aspects. So the end objective of this session is that you will get a very top level hang of how the data analysis and visualization happens. And if this interests you further, you can go through some courses on this. And probably, if any of you are trying to move into data science from other domains, this should help you to gauge your such movement in terms of your career path. Okay. So that would be the objective, and this is the agenda that we are going to go through. This is roughly 45 minutes to 50 minutes of session, right, with some coding also. So many things could fly over your head in terms of coding syntax and so on, because it is important to know the Python language. But otherwise, don't worry about it, right? This should help you to gauge, to check if this domain is interesting to you or not. And you may want to take any courses from anywhere for that matter to go further on this data science domain. So let us move forward. Overall, the data science flow. So data science is basically, see, data science has been there for data analysis has been there for a long time. For example, we have had satellite images for a very long time now, right? ISRO has been around. There's been a lot of weather maps that used to come, the cyclone maps that used to come. The only thing was once the cyclone map is captured on the satellite, it was probably transmitted by fax or something to the IMD. The guys there would analyze and then say where the landfall would be and so on. And by that time, the response is ready. The cyclone would have come and gone. It would have done its job of destruction, right? So data analysis has been there for a long time, only that it was manual in nature, right? It was completely manual, right? What we are trying to do now in today's world in terms of data science is real-time data science. We have a question, we have the data, and I want the answer now, right? Right? Previously, if somebody had to buy a certain stock, you used to call a broker locally. That guy used to call somebody in Mumbai. They would call somebody in the stock market. They would see the data. They would call back, and by the time the stock price has changed. But today, you can get real-time data of the stock market. Of course, it is paid, and you can make your decisions. So today's data science, the real definition is real-time data science. We want answers now based on the data that we have, right? So it is something like in cricket, you have this, projected score, right? How is the projected score calculated? It is modeled basically, right? You have the current facts, and basically you have some parameters like wickets remaining, balls remaining, and so on. And based on that, you do a certain projector, certain projection, right, through a certain model, linear model or classification model or whatever, right? So so the data science that we are talking about today is real-time data science. Data science. It all starts with a question, a business question or a policy question. Okay, the cyclone is there. Where will the landfall be? Okay. So based on the data, you would gather the data, clean up the data, and explore the data and find out visually where the landfall would be. But then there are some questions that will be asked. Oh, what if the speed changes by 10 kilometers per hour? What if the direction changes by 5 degrees northeast or east or north, whatever, right? What will happen in such a case? So that is where modeling will come into play. Exploration is factual analysis. You have the data. What is the result what is the question? How is the question answered factually through this data? Modeling comes in for prediction purposes. What if some of the parameters, input parameters change? How would the end result look like? Right? So that is what is data modeling. So this is where concepts like machine learning, deep learning, all of those aspects come into the data modeling phase. But whatever it is, whether it's exploration or modeling, uh, other than engineers, the rest of the policy makers, they understand visualization only. They don't understand numbers, right? Numbers we engineers understand. We have to visually present it so that somebody at the very top can make a decision out of it, right? So we, the engineers, we play with the numbers and create some visualization around it and allow the policy makers to make a decision, right? All real time, right? All real time. This is a very simple way of putting through data science flow. Each of these boxes is a huge amount of work that happens, especially data gathering. Data gathering could be an audio bite or some video clip. It needs to be converted to a format which the computing engines would understand, right? And once it's done, data cleaning, so there could be some missing data, there could be some wrong keys that are present in the data. They need to be cleaned up. And once the cleanup is done, then the data is ready for exploration as to what is there inside the data, and modeling. What if some of the inputs that are present in the data changes? How potentially the output could change, right? So when it comes to modeling, a part of the data is used to train the model, right? Or after the cleaning of the data, a part of the data is used to train the model, and a small part of it is used to test the model, right? And for example, if you have pictures of different types of dogs, right? So a lot of data is pushed into the model, different types, different breeds of dogs sitting in different postures and so on, right? And then you give it to the model. The model will be trained to detect dog images. So you give any other type of dog, it should be able to spell out that it's a dog. Right now, you look at many markets, you just keep the vegetables or the fruits, and the scanner takes it and then detects the text of the fruit or the vegetable or the grocery item, right? So that is where the modeling, the training and testing comes into play. This is what is data modeling. We are not getting into the data modeling. Again, as I told you, if you find this domain interesting and you want to make a change, you can go through the training sessions from Greater Insights, right? And then, change your career if you like to get into data science domain, which is very hot nowadays. So we will talk about data visualization using some samples, right? Let us move forward. Next is just a quick thing about Python, right? So Python is a general purpose programming language, very high level language, object oriented, very simple. It's not just for computer science guys. Anybody can learn Python very easily. It's the first language of choice across universities, right? Free and open source, completely object oriented. And data science is used not just in it is a computer science activity, but then it is used in steel plants, it is used in railways, it is used in cement plants, it is used in automobiles. So you need to have the domain expertise to understand the data. So we need mechanical engineers, electrical, civil engineers. It is used in genetics. So you need guys from life sciences, right? A lot of text processing happens in the literary world. So, English language comes into play there. Different languages, data has to be processed. So data science is not just about some technical stuff. It is used in non-technical domains also, and everything has to be visualized because that is the best way to understand, correlate, compare, and decide on the data that we have. In terms of libraries, you take Python, it scales up very nicely to any domain. The native Python snapshot is just the programming language, but then you can import different modules for different domains. You think of a domain, there is a solution in Python to work on specifics of those domains. For example, you want to talk to a SQL server, there's a PyMySQL module which will allow you to connect to a MySQL server, get the data, process the data, and query it back again, right? If you want to work on Excel, you don't need Excel, Microsoft Excel at all. You need the OpenPy Excel module of Python. Using that, you can create the Excel. Whatever you can do with keyboard and mouse on Microsoft Excel, you can do it Pythonically using the OpenPy Excel module, and so on. So you think of a domain, there is a solution in Python. If you are into web frameworks, right? Django, Flask, these are very popular. If you are into machine learning, scikit-learn, TensorFlow, these are very popular. If you are into testing, unit test and PyTest are very popular, and so on. You think of a domain, there is a solution in Python. So in terms of data analysis, 4 modules are important: Pandas, NumPy, Matplotlib, and Seaborn, right? These 4 are very important in terms of data analysis, right? And what is the internal architecture? So Pandas is considered data mover, right? Data reshaper, and so on. We call it the big boss of data analysis. Everything, any data that is there which needs to be analyzed has to be converted to a Pandas data frame, right? That is a key module. NumPy is numerical Python for n-dimensional array processing. So our interest today is Matplotlib, wherein we would like to do some plots using Matplotlib. So if you have a data set also, we would like to read the data set and take in some features from the data set and do the plotting on them so that we can visually inspect the data, right? And Seaborn, of course, also is another module, visualization module, which has got its own top layers, but underneath it uses Matplotlib for the final depiction, for the final uh, image dumping. So Matplotlib and Seaborn are the important visualization libraries in Python. There is others also. ggplot is there, Plotly is there, and of course, external to Python, you have Tableau and Power BI, which are GUI-based visualization tools, right? Some aspects of these two tools are free also. There are some public snapshots of these two tools that are available, which are free. Otherwise, overall Python, if you take, everything is free and open source, right? If you want to do programmatical automated data science, that is where Matplotlib and Seaborn comes into play. Okay. Now, in terms of Matplotlib, which is the focus for the day, the way Matplotlib is organized, let me just go to the Teams and see if there is anything. Okay. Okay, good. Coming to Matplotlib plotting, right? So you see a sine wave here, correct? We see a simple sine wave. We all have seen sine waves, right? So this is a plot. This is a typical example of a plot. So the basic architecture of Matplotlib plotting is there is an object called figure. For example, before we get here, suppose you want to draw something, right? What would you do? You would first have a white sheet or something which you call as a canvas, correct? The drawing canvas, a white paper or a white board or some board, right? And then you need to have an object, right? A graph object. If you want to do drawing, you need to create an object in your memory as to how the image should look like. And your hand is the rendering tool which will transfer the image in your memory onto the canvas, correct? And then you will put your signature there, the date of the image, all of those stuff, who wrote the drawing, who created the drawing, who did the painting, all of those signatures are put. And finally, when you look at the whole thing, your painting your artwork is ready, correct? Similarly, here also, there are several graph objects in this particular image. There is a sine wave here. There are some numbers here. There are some alphabets here. Some alphabets are on the x-axis. Some alphabets are on the y-axis. Some numbers are on the x-axis. Some numbers are on the y-axis. There are some alphabets called title and so on, right? So there are several individual graph objects which are dumped on the same canvas. And finally, when you see all of them in totality, you will see a Matplotlib figure, right? So figure is the name of the canvas. The equivalent of canvas in your drawing and painting is a figure, right? So one of the graph objects is this sine wave. This is a line plot. The another graph object is the x tick values. This 1, 2, 3, 4, 5, 6 you see on the x axis. Those are called as tick values. You see this string called x label. That is the x label string. Similarly, you have y ticks and y labels. There are so many different signatures which are superimposed together on the same canvas called figure. And then when you see all of them in totality, you have a matplotlib figure. So a plotting in plotting, there's not only one graph object. There are several types of graph objects, right? They're all dumped on the same figure. And finally, when you show the figure, you see all of them together, right? Another example I could give you is, suppose in your meeting room, there's a whiteboard. I alone can draw something on the whiteboard. So whiteboard is a canvas. Whatever text I draw, images I draw, date I write, all of them are individual graph objects. So we'll say that this canvas has got uh, one figure object. Everything put together is one figure object. Similarly, if there is a whiteboard, four of us, we can convert it to four quadrants and have four figures, four images there. For example, here the entire thing is one figure divided into 2 cross 2 array, right? So this is row 0, column 0, row 1, column 1, row 1, column 0, row 1, column 0, and row 1, column 1. So on row 0, column 0, you have a scatter plot. Then you have a line plot. You will have a pie chart here. And we have a bar plot here. This is called as subplotting. For example, if you look at some financial channels, right, like CNBC or NDTV Profit, if they are discussing the stocks of companies in the same sector, they'll generally try to show some common uh, stock attribute of all the four companies together, right? So they'll show it like, for example, earnings per share. Earnings per share is the efficiency of the employee, right? Or employee earnings per share is earnings per share is one aspect. Uh, Earnings per employee also is another aspect. Suppose the organization has got 100 employees, another organization competitor has got 50 employees, and they have the same revenue, then the 50 employee organization per employee, they are earning more. That means their efficiency is more, right? So that also is a comparison tool, right? In India right now, we have 70 hours discussion, 90 hours discussion, right? So this is where efficiency comes into play, right? We like it or don't like it, but that is what is a comparison tool also. Okay, so this funda is called as subplotting, right? Remember, guys, this is just a 1 hour session. So I'm trying to speak out as many keywords as possible. You can jot down and then probably start Googling around and so on, right? So, so what we do now is we directly jump into a demo. Probably we look at scatter plot and then we will look at the COVID-19 data set. Okay, so coming back here, so I'm using the Jupyter notebook, right? So let me import, see, typically in data science, we import pandas as PD, right? And we import matplotlib.pyplot. So in the matplotlib package, there is a module called pyplot. We will import it as an alias called PLT so that it's easy for us to type. And then we import the Seaborn package as SNS. SNS is the first name of a guy whose last name was Seaborn. You know, that's how it's used, right? So these three we will import, right? And let us quickly, what we will do is, as the import is going on, right? We will, from Seaborn, let us load a data set. So let us look at the different data sets that are available in Seaborn. There are several built-in data sets available. Let us load the MPG data set into the data frame. sns.load data set MPG or miles per gallon. Let me take it as DF1. So this is the data set Two-dimensional data set. Data sets are all mostly two-dimensional, which has got around 398 observations across 9 features. So 398 rows across 9 columns. So it is the data. MPG stands for miles per gallon. This is US data set, right? Of different cars. They are all listed here. So what is their mileage per gallon? How many cylinders are there in the car? What is the displacement? What is the horsepower? What is the weight in tons? What is the acceleration? Acceleration is the time taken to reach quarter of a mile. So, right, and so on. Uh, acceleration, no, acceleration here is the physics acceleration. There's one more data set, and in which year did this car come out, and where is the origin, right? So like this is the data set. So we are supposed to analyze. So what are the analytical parameters? Oh, which country's car gives the best mileage, right? Uh, which country's car is always weighing more? Which parameter? I mean, this is a very small data set, MPG data set. There are many more features, right? Which parameter should I tune to increase the mileage, right? If you look at the correlation, which parameter is affecting the mileage heavily, right? All of these parameters will be part of the automobile data set, right? So an automobile data science engineer will look at all those parameters and find out, and the expectation of the automobile engineer is which parameter, if I tune it minimally, will give me the best increase in mileage, right? I'm just giving an example of automobile. Every other domain also, there will be one parameter generally, which if you tune, it will increase the efficiency, right? So how is that parameter detected? Through data analysis of different observations, right? Through data analysis of different observations. For example, you take some big shopping mall. Uh, what are the aspects of a shopping mall in terms of business? There must be footfall, correct? That means people must be able to come in. People should feel that they are able to walk around the mall and do the shopping, right? So there must be enough space, and of course, there must be enough material to purchase also. It has to be arranged very well, correct? So there is data for that also, right? Where should each product be placed? Where the heavier one should be? Where the lighter one should be? Where the costliest one should be? Where the cheaper one should be? Right? All of this, there is data to find out the how based on the psychology of the customer, and based on that, they're all organized in in grocery shops, right? Just before you're just near the counter, you find a lot of chocolates, a lot of small items, right? Like cookies and so on. People, when they are deep inside the store, they'll say, "Oh, not needed. This will increase the weight. This is health hazard, that, this, and so on." But by the time they come closer to the checkout, when they see all those things, and they'll be standing there for a long time. There's a psychology. There's temptation, right? And kids would be there probably. There, they would have said no, but here, there's almost getting out, right? They just take two or three and then move on. So they play on the psychologies also. And all of this is captured in terms of data, right? Data is captured. A particular product, right? Like chocolates, where should it be placed in the shopping mall so that, most people buy it? Every minute thing is captured in the form of data and analyzed, and that is how they're all organized. And many stores, if you see, there could be different branches. They're all organized in the same way, right? So that any store people walk in, right? If they are a permanent customer of that company store, they know where a certain product is. So that's how they're all organized. Okay, so we load the MPG data set, right? So let us do a plot now. So let us do a scatter plot. Plt.scatter is the function to be used for scatter plot. On the x-axis, I'll put the weight, and on the y-axis, I'll put the MPG, and let us see how the plot will show. Okay, so I'm plotting weight versus MPG, right? This is how it shows up. This is the plot using Matplotlib. So we have 398 observations, right? All, so what happens is, if observation number 0 is taken, what is the weight? 3504. So on the x-axis, you go to 3504. And on the y-axis, you have 18, right? Where is 3504? Somewhere here, 18 somewhere, a scatter is done. So like this, you have the scatter. So what is the analytical inference from this particular scatter plot? This clearly says that in general, as the weight increases, the mileage is decreasing. And from where did these numbers come? These numbers came in from the data. So the minimum of the weight was taken, the maximum of the weight was taken, and that was divided into linearly spaced numbers and then plotted on the x-axis. Similarly, the minimum mileage was taken, the maximum mileage was taken, and then drawn. How do you find out? So df1.mpg.min. So min is 9.0. So you must you must see a scatter somewhere at 9 here. Probably this is 9. And df1.mpg.max somewhere. This must be 40, 45, maybe 46, 47, right? 47, 46.6. So it looks like this is the 46.6 scatter, and its weight is somewhere in the range of 2000 plus, right? Somewhere here. This is the weight. Okay, so this is the Seaborn, this is the Matplotlib's plot, right? Let us put some labels, right? Just for example, plt.x label. So what is the x-axis? Weight. Plt.y label, so which is miles per gallon, right? And let us run it. So you see the x labels and the y labels come. And then we can also put a title for the entire thing. Uh, uh, Mileage plot, some title, mileage plot. So I got a nice title for the plot. And of course, you can save the plot on your hard disk and email it to somebody using the Python's SMTP module, miles.plot, miles.jpg, JPG. Okay, so it should be on the hard disk somewhere, right? It will be stored in the hard disk, and you should be able to take it out and then. So let us see if it's loaded on the hard disk. Is there a miles? Yes, there's a miles JPG. Okay. There's a mileage plot. So you can take the SMTP module of Python and email it to your manager, right? So like this. Similarly, if you look at Seaborn, right? SNS.scatter, right? So X is df1 dot weight and Y is df1 dot mpg, correct? So this is the uh, scatter plot. Okay, here it is scatter plot. Different signatures, right? The same data presented by Seaborn. One of the advantage of Seaborn is you can add a hue. So I can say hue classify based on origin, right? So like this. Now, if you take this, I've added a third level of classification. See, see, weight versus MPG correlation is being done here anyway. But just before the scatter, right, the origin of the car is taken, and for different origin, different colors are dumped, right? So if you take the scatters, they are all the same. But you can also get one more level of information here. What is the information that you can gather now? As weight increases, mileage decreases. That's for sure. But then you find that the heavyweight cars are generally coming from USA. And the highest mileage car is coming from Japan here. And the European cars are also spread in terms of their weight. There are a few heavyweight Europe cars. There are some lightweight Europe cars. But the least weight cars are also coming from Japan. So this is what? This is the third level of information. One is weight versus MPG you did. Now one more level of analysis you can do from this, right? Using the hue parameter, right? Hue is the word used in the imaging industry. Hue means, boss, X and Y, you are putting a scatter, but just before you put a scatter for the, let us classify, find out, for example, df1 dot origin, right, dot value underscore counts. How many values are there? There are only three unique values as USA, Japan, Europe. So USA, there are 249 cars, a lot of blues you see, and Europe and Japan almost 70, 70, 79. So you must be seeing equal number of green and orange scatters here, right? So there are three unique values. So you're seeing three different colors. It's the same scatter between weight and MPG, but just before the scatter, find out, classify the scatter color based on one more column data. Based on one more column data. Basically, what we did, weight versus MPG, we plotted scatter plot, but we also took the origin parameter to for one more level of classification, right? So this is a very simple example of what can be done using plotting. We are just scratching the surface of plotting, guys. There are so many things that can be done in plotting, right? So this is one part of the story, right? Just wanted to introduce to only one plot right now. If you start working on Seaborn alone, right? If you want to become an expert on Seaborn alone, easily it will take you 1 to 2 years. And similarly, Seaborn and Matplotlib both. Pandas will take much more, right? So there is no one person who knows the entire thing of Matplotlib or Seaborn. It will take time. But then you get the hang of the syntax, you get the hang of the concepts behind the plotting, the architecture behind the plotting, what is label, what is title, what is scatter, what is hue, what is x-axis, what is y-axis. All of these conceptual aspects, if you know, then you can do any plotting. You just have to read the, for example, here, scatter plot, how it works. I just say shift tab, I can read the help. In Jupyter Notebook, I can read the help of scatter plot, right? So like this, I can read the help of scatter plot. Now, in terms of line plot in Matplotlib, we can say plt.plot. On the x-axis, let me put weight. On the y-axis, let me put MPG. This is how the line plot looks like. So unexpected argument. Okay, so this is, we should not be giving names. We should not be giving parameter names. Directly pass the values. This is a scatter plot between, and this is the line plot between weight and MPG. So it correlates with the scatter that we had. Only thing is when you look at the data set, right? When you look at the data set, first column row number 0 was plotted, right? So weight was 3504, MPG 18. Then 3693, then the plotting engine went to 3693 on the x-axis, then 15, and drew a line between those two plots. Similarly, and so on, right? That is why it looks so haphazard. In fact, if we sort one of these columns, right, df1 dot weight, df1 dot sort underscore values by equals weight, right? WEIGHT. So if you sort by weight, now the weight is organized in ascending order. Now on this, if we do the plot, what happens? On this, if we do the plot, what happens? Dot plot. Um, WEIGHT, comma MPG. Right? Now it is well organized. Because now you see, see the difference between the two plots. It's very haphazard because the data was not sorted. Now we have sorted, so the weight keeps on increasing. And of course, you can put one a marker here. Marker equals star. Right? Now every value is marked and then lines are drawn. And then the lines are drawn continuously. Right? So this is how many more things. Data reshaping can be done, sorting can be done, grouping can be done, pivot tables can be created using pandas, right? Melting can be done, stacking, unstacking. So many different reshaping functions can be done using pandas. So this is one part of the story. Let us now move to the COVID-19 data set, right? So let me get to the COVID plots. Right now, if you see, there's a directory called COVID plots, which is empty right now. So what are we doing here? Right, we have loaded the required libraries, mainly pandas and matplotlib. So what we want to do here is we would like to request data from a website which is a REST API enabled website, and that is this website. So during the COVID days, every day's data starting from 2020 March 10th, if you guys remember, data was collected for every region, Delhi, Haryana, Karnataka, and so on, all the way till the end of the year. So what is the end of the year date? So if you look at the last date, the data was collected, it was 2021. That means almost 24 minus 3, 20, almost for 21 months they have collected the data, right? So all of the data has been, for every day they have collected data from every state that has reported it. There's an overall summary in the data set and region wise, Andaman and Nicobar, how many confirmed cases that day, right? Andhra Pradesh, how many cumulative basically, right? So for every region that was reporting, the data is collected for Indian cases, foreign cases. What is the cumulative discharge? What is the deaths, total confirmed, and so on. For every day, this data has been collected. So this is the REST API, right? Now, using the request module, right? Using the request module, I imported the request module. We can we can put the API, the REST API there, and the data is stored in the REST API in the form of JSON script, right? We collect it from the REST API and convert it into a pandas, a Python dictionary, right? So there is also last refreshed data. If you go to the last, there's a last refreshed date, last origin update date, and so on. So we are deleting all of them, right? And once we run this, our data is collected in the form of a Python dictionary, right? So the JSON data on the website is now sitting along with us in a variable called R. R means here return in the form of a Python dictionary. Since it is in the form of a dictionary, I can't do much. I need to convert it to a pandas data frame so that I can apply some techniques, right? If you see this through pandas also, if I have a data frame using Matplotlib, I can push in the data frame. Using the data frame through pandas also, I can invoke some plots. So I need to get it into a form of a data frame to enable the plotting very easily. Otherwise also I can do it, right? So what we do next is we scan through the entire data set and create the pandas data frame. So we go through we start a loop here, a for loop, collect for every data for every day's data, we collect the regional data and concatenate one by one all of them together. We stitch the entire data frame, right? And we do some renaming of labels, calculate the percentages of uh, death, active, and recovered. D for death, A for active and recovered, so that we have the data in the form of a data frame, which will take us further for plotting. So let me run this. So this is the one time consuming because it is going through nearly 20 months of data right now, right? And then the data has been collected. And this is how we are printing the last 5 observations of the 20-month data. So this is how it looked, right? On 2021, December 15th. So total data overall India was what? 3 crore 47 lakhs 10,598 cases. How many were discharged? 3 crore 41 lakhs and so on. How many deaths? 4 lakhs 76. What is the total confirmed cases? And so on, right? Total confirmed Indian cases. So this is the certain numerics there. So, and then what is the active? How much active remaining? What is the recovery percentage? 98.37 recovered. Death percentage overall India was 1.37% of the cases died. And what is the current active? 0.25% of the cases are still active. That means they are still going through that containment period. They are still not declared recovered. Declaring recovery initially took 21 days. Later, in the second wave, they reduced it to 7 days. And the third wave, they reduced it to 3 days or 5 days. In fact, I got COVID in the third wave. After 3 days, they declared, there is no need for any isolation and so on. So like this, the data is ready. So this tail function is only the last 5 rows. Okay. This tail function is the last 5 rows, right? So much of data is now accumulated in my data frame. Next, what I'm doing is I'm setting up a function, right? Percentage of active recovery. So I've been experimenting on this. So this is my third version, right? Wherein I do subplotting, right? So I do subplotting like this. So how does the subplotting look like? So in 0, 0, I'm doing a certain plot. In quadrant 1, 1, I'm doing a certain plot. In quadrant 0, 1, certain plot. And in quadrant 0, 0, certain. Quadrant 0, 0 is bar plot. Quadrant 0, 1 is pie chart. 1, 1 is a line plot. And 1, 0 also is line plot on different parameters of the data, right? So I'm setting up the function here, right? I'm not going to go into the details of the function, right? And then what I'll do is I'm going to create a directory. If it is not existing COVID plots directory, if it is not there, I'm going to create it. And then what I'll do is for Maharashtra alone, so I'll scan through the entire data. For Maharashtra alone, I'll do the plotting. Right now, there is nothing here. So let me run this plotting engine for Maharashtra. It's going on here. So let us see if we get a JPEG image here. We should get it very soon. Yes. So we got Maharashtra's data here. Let me open it up. So I told you we did a 2 by 2 plotting, right? This is Maharashtra's data overall on 2021 December 15. So let us look at the pie chart, right? Recovered was 97.92, active was still 0.15, and disease was 2.13%. And remember the two waves. Do you see these waves here? So this is the line plot. On the x-axis, you have 2020 March 10 all the way till 2021 December 8. So this is weekly. Looks like weekly plotting. You see the waves. There were two important waves. The third wave came in 2022 January, February, right? So this is one wave, which was somewhere in, it started sometime in July and went all the way till October. At that time, you see this black line here, that's were very minimal because we were very, very careful. Then we loosened up a bit and then see here, the death increased also here. And the second wave was there for a long time, right? But of course, recoveries also happened. And if you look at this plot here, right, this is also a line plot on grid 1, 1. This is the percentage. So initially, the active percentage was high, recovery was low, deaths was very high initially because we didn't know how to handle. We didn't have masks. We didn't have many of the stuff, right? But then the recovery started increasing, so the active started coming down. And overall, by the time the second wave came, the death percentage was less. We lost more people in the first wave, guys, because we didn't know how to handle it. But the number of cases in the first wave was less. So a huge percentage we lost in the first wave. But by that time, second wave came, the amount of people who got COVID was very high. But the percentage of people who succumbed to that was low. That's what the data is saying. I'm not saying it. It is the data. Initially, there was a lot of issues in terms of coordination between the central government and the state governments and so on. Right? This is Maharashtra data. So this is how. This is one plot, and here the cumulative data of the COVID data. Right. See, initially we had active. So as the recovery happens, the recovery goes on more. The red portion is the active, and cumulative deaths also started increasing over a period of time, right? So this is the four data, right? And then the last functionality is plotting for all states, right? So this is the state list. So if this state name is present in the data set, that data alone, that observation alone will be picked. So what I'll do is instead of going through all the states, let me go to the first 10 states. First 10 states, colon 10. This is a state list. Colon 10 means 0 to 9. So so I should get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So from overall India score to Rajasthan, I must get the plots. So let me run it. So India plot is going on. So let us take a look at it here. All of this should start appearing in this particular, yeah. So we have the overall India data here, right? This is the overall India plot, the two waves, if you see here, right? So like this, it's still going on. Right now, Karnataka is going on. So Karnataka should appear, yes, it has appeared here, and so on. So this story goes on and on. So Tamil Nadu is interesting. If anybody is from Tamil Nadu, let me give an important context in Tamil Nadu. In Tamil Nadu, in Chennai, right, there is a market called Coimbatore Market. If anybody is from Tamil Nadu, I remember those days. I'm sitting here in Bangalore. That market opened up for 1 day annual fair or something. Some fair, I don't know what is that name. So many farmers came from nearby districts to sell their produce there. Let us get Tamil Nadu data to analyze this particular happening here, right? So in fact, always they should say Tamil Nadu model, Tamil Nadu model. In fact, Tamil Nadu was doing very good, right? If you see here, Tamil Nadu acted very swiftly to increase the recovery and reduce the active. But this is the place where the Coimbatore market opening came up. Again, active went up, recovery fell down. And of course, after that, the isolations happened and so on. You see this here? This is this plot. Very exactly correlates with what happened in those days, right? So like this data is correct. Rajasthan. Rajasthan came here. Yes, Rajasthan. And once this is done, uh, you know, everything is over. So the plotting is done, right? So all our analysis. So we wrote a code to analyze. By looking at all these images now, anybody can analyze, right? If you show this code to the politicians, they don't understand anything, right? But if you give this to those officers or politicians who want to make decisions, so they understand why it happened, how it happened. All of these stories for every state is recorded in this data like this, right? So this is how data visualization helps us to understand the current scenario as well as uh, any predictive aspect. We didn't cover the predictive aspects here. We just did data exploration. That means actual data we explored and found out what are the um, hidden attributes of that data, right? Okay, so this is what we wanted to cover in this session, guys. So now, anybody, I'm going to stop sharing. Anybody has any questions, uh, you can ask, right? Uh, so Manish, I'm open for any questions for the next probably 10 minutes. And then,
Yeah,
no.
yeah. If anybody has a question, they can raise their hand. I will unmute their mic for a while.
In fact, anybody wants to give any feedback on this session, please feel free, feel open to do so, right? Go ahead, speak your mind out. This is just a quick presentation with the 1 hour we have.